Alright, so I think I'm recording. We're asked to build a new function given two functions f and g. We're going to build this new function through subtraction. So what this notation means is to take g of x and subtract from it f of x. So g of x is this quadratic function, x squared plus 3x minus 5, and we're subtracting from it this line, this linear function, 1 minus 4x. So it's combining like terms and trying not to make silly arithmetic or silly sign errors. We only have one x squared term. We've got two linear terms. So we've got x squared plus 7x, and we've got two constant terms, minus 6. So there's my answer for part A. Let's move on and take a look at part B. Again, we're given the same two functions and asked to build a new function, this time through multiplication. So we've got, let's illustrate that it's equal to f of x times g of x. So f of x is this binomial, g of x is this trinomial, this quadratic, so if I use the distributive property and take this number 1 and distribute it through the three terms, I get x squared plus 3x minus 5. If I distribute this negative 4x through these three terms, I get negative 4x cubed. I've got minus 12x squared, and a negative times a negative is positive, and I've got 20x. So I have one cubic term. I've got two squared terms. I've got two linear terms. And I have just a constant term of minus 5. So there's my answer for part B. In part C, I'm asked to build a new function through division to take f of x divided by g of x. F of x is 1 minus 4x. Now this g of x, I cannot factor it. So this is my answer. Alright, so let's take a look at this composition. G is this quadratic, and that's the input into this linear function. Well, what does f always do to the input? F always creates a subtraction problem, 1 minus 4 times the input, and this time the input is this quadratic, x squared plus 3x minus 5. If we distribute, we have 1 minus 4x squared minus 12x plus 20, which is negative 4x squared minus 12x plus 21. If I haven't made any silly mistakes, that's my answer for D. Let's stop there, and I'll do this on the next video.